Let's find the sum of a geometric series. So let's consider this series 2 minus 2/3 plus 2/9 minus 2 over 27 plus dot 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 dot. So we don't really have to figure out what's next. We can do a little bit of algebraic manipulation to see that this is a geometric series, and then figure out what A is and figure out what our fixed quantity, that is our common ratio, is. So let's start with our series 2 minus 2/3 plus 2 over 9 minus 2 over 27 plus dot dot dot. If you notice, all of these have a 2 in common. They'll have a 2 in the numerator, in fact. So if I can write, not if, I can write the number 2 as 2 over 1, it becomes clear that they all share a 2 in the numerator. So let's factor that out. So this leaves us with 1 minus 1/3 plus 1 over 9 minus 1 over 27 plus, and so on we go on. Are you seeing a little bit of a pattern here? I'm seeing that I have 3 here, and I have 9, and I have 27, and I know that 3 squared is 9, 3 cubed is 27. So what I'm seeing is our common ratio. But I also have this minus and plus sign. So I know at least that the common ratio has an absolute value of 1/3, and I have to figure out a way to tease out this plus or minus sign. So I'm going to take another step here. So what do you notice? I have an exponent of 0, 1, 2, 3, and look, I can even put a negative sign here, since anything to the 0 power is just 1. And doing that gives me these terms. Negative 1/3 to the 0 power is 1. Negative 1/3 to the 1 power is negative 1/3. Negative 1/3 squared is positive 1/9. Negative 1/3 cubed is negative 1 over 27. This tells me that r equals negative 1/3. In order to get the next term of the series, we multiply the previous term by negative 1/3. So let's see if this works out. So if we start with the first term of a sequence, a1 is 2. a2, I am saying, is 2 times negative 1/3. That equals negative 2/3. Great. a3 is equal to 2 times negative 1/3 quantity squared. That's 2 over 9. And let's check one more. a4 is equal to 2 times negative 1/3 cubed is negative 1 over 27. Sure enough, this sequence of numbers is a geometric sequence, and the sum is a geometric series. So now that we know what r is, what is our first value? Well, that's 2. So we say a equals 2. And then since this is a geometric series, we can write this as the sum of 2 times negative 1/3 to the n minus 1 power, where n ranges from 1 to infinity. Alternatively, you could write this as the sum from 2 times negative 1/3 to the n power, where n ranges from 0 to infinity. And I wanted to show you 2 ways to do this, just so you can see that this and this are the same. Here we'll start with 0, and we'll get this term. Here we still begin with an exponent of 0, but we start at n equals 1. 1 minus 1 is 0, and that gives us this first term. Now that we're certain that these are equivalent, let's recall our definition from the previous video. This is just going to equal a divided by 1 minus our common ratio. And before I write this down, I'm just going to write this little reminder here. So here is our reminder. If we have this infinite series, our sum is a over 1 minus r. As long as r has an absolute value that's less than 1, our r is negative 1/3, and the absolute value of negative 1/3 is certainly less than 1. So we can write this as 2 over 1 minus 1/3. And I'm going to make a little space by erasing this. And if you notice, this geometric series converges and it sums to 6. So if we were to add up this series for ever and ever and ever, we would get the number 6.